Hello there, back at you at another problem called Hand of Straights. This is another greedy problem. Greedy problems are pretty interesting, I think. So in this particular problem, we have a hand, and we need to group them in sizes of 3. And so here we can't do that because it's a 1, 2, 3, 2, 3, 4, and then 6, 7, 8. And here we cannot. The reason being is that they cannot divide equally into this hand immediately. You know that is false. So the first thing we do is if the length of hand modulus group size, if that is 0, then return false. If it is equal to 0, does not equal 0, return false. Wait, return true. I don't know if that's right or wrong. Let's check it out. I don't think it's right. Oh, it is right. Okay. If it does not equal 0, return false. That makes sense to me. Otherwise, the other way is if it is 0, then don't do anything. You can easily do it like that as well. So let me show you. Run the code. Also works. Okay. I think this is more clear, so we'll do that. Anything else? So with that, we can use a heap to go with from the smallest to the biggest item, because they all have to be used, all numbers, and it has to be consecutive. So we have to start at the smallest number and go to the biggest number. This is why it's greedy. And right, so the fastest way we can grab the smallest number in our heap, in our dictionary, is that we want to use a min heap. This is a log n operation, and we need to do this for all the keys, which is n times. So let's create the count equals the default dictionary of int, and for n in hand, count of n plus equals 1. And with that, let's make our min heap out of all the items so that we can pull these items out properly. So while min heap, let's set the first item to be equal to min heap of 0. And we're going to go for the nums in range of the first all the way to the first plus group size. So if num is not in count at this point in time, then we could return false. Otherwise, count of num is minus equals 1. So once the count is hit, we can remove the first item, that particular item, from our queue. And then lastly, we return true. Okay, that looks good to me. So submit. Alright, pretty good. Right here as well, if we take away this, I think we can speed that up a little bit more, but it's just less readable. So a question, what if we pop the wrong number, right? That's a possibility. Let's just say can we pop the wrong number from our heap? I'm sure that's possible. Like there is a number, let's say here, in this example here, we get 1, 2, 3. You see there's only 1, 2, and 3. So now we have 1. We popped the 1. We're gonna have 2, a 3, and a 4. I'm sure we're gonna pop the 2. Like, right? We're gonna pop the 2. And then, so we pop the 2, and we are, you know, we see it, it's 0. We pop the 2. We see the 3. The 3 is not in the count, so it turns false immediately, and then we're good. So it cleans that up right there with this if num not in count. Yep. Pretty good. So what if, yeah, I think that covers all the possibilities. And with that, I think we have solved this greedy problem. The idea here is that we need to figure out where can it go wrong. If these things don't go wrong, then it must be the case that this goes right. And the thing that does go wrong is if the group sizes are incorrect here, or there is one item that is not consecutive when we start at the smallest number that is available. And that's how we check for this. Then we know for sure it's a hand of straight. So it's an idea about logic, about eliminating the possibilities, which possibilities make it like possible or impossible. So to be not that, to be not a straight hand. So that's it. I hope you learned something today. Enjoyed today's video. Please like and subscribe. If you want more videos, check the link in the description below. And if you have any questions, please comment, and so I can think about your question and answer it maybe. All right, thank you very much. I'll see you in the next one.